And I will continue my presentation to talk about demand control ventilation based on some international standards like an ISO 17772 and an EN 16798 and ASHRAE 62.1. Okay. So demand control ventilation based on CO2 is already used today. And it's now also being dealt with in different standards. So the ASHRAE 62.1 from 22 has in 23 got an addendum where it talks about demand control ventilation and give guidelines and requirements. The two other standards I mentioned earlier, ISO and EN, do at the moment not have anything about control of ventilation, but they are both being revised. And in the revision, we are now decided to include also operation of system and the use of DC demand control ventilation. So we have a discussion on this issue. So in general, the use of CO2 as an indicator of the ventilation needs per person. And we have seen in DCV controls today, often you use a fixed set point of 1000 ppm. But there are some issues with that because for the same indoor air quality level, the CO2 set point depends on level of building emissions and people density. Also, we can see outdoor concentration that can vary between 350 and up to 550. So if you use just an absolute value, you don't take into account the variation in outdoor CO2. And then it's often a question, I think we will get back to that, where should your CO2 sensor be in the space? We have data showing that the CO2 concentration is not uniform in the space. In all the standards I have mentioned, the concept of estimating how much you should ventilate is basically the same. So you have contribution from people, what we call the people component, and you have contributions from the building, which we call the building component. So the people component depends on how many people you are in the space, and we have table values in the standard telling how much you should ventilate per person. And for the building, we also have for different spaces, there's some areas or some values for liters per second per square meter you need for this space. So you just need to know the area. And that's how you get to the total ventilation rate required. And this is based on basically what we call the perceived air quality. So in the ISO and the EN, we have a table like this. So you see in the column for airflow per person, we talk about different categories and which are related to the number of people we could expect to be dissatisfied, people who are not adapted coming into a space. So we will require about 7 liters per second per person for indoor air quality category 2. This is 20% dissatisfied. That's also the basis, for example, used often in 62.1. But in ASHRAE 62.1, they used for sedentary airflow 2.5 liters per second per person. So significantly less than we recommend in the ISO and EN. We have it in the fourth category. We can go down to 2.5. And then we have a building component, which depends on if you have low polluting building or you have a very low polluting building where there are different requirements to the emissions from the materials you have been used. So by improving the building, you can reduce the required ventilation rate. In the ASHRAE standard, there are tables with different rooms where you both have specified the people component, which for all sedentary work is 2.5. And then there is a value also for the building component. So that's how the standards are built up. If you now look at the EN and ISO and make like a table for the different categories, let's just take a single office. We have a low polluted building. We will have to ventilate with 14 liters per second per person. We can also express that as 1.5 liters per second per square meter. And similar, you can find if you have the floor area per person, the density of people, and what is assumed to be a low polluted or very low polluted building, you can find what is the required ventilation rate. In the ASHRAE standard, you have a tables which give you the value directly. If we now were using this required ventilation rate and looking at the production of CO2, then the equivalent CO2 concentration to give the same air quality, if again we look at category 2, would for a low polluting building be, for example, about 397 ppm. But if you had a very low pollutant, you could go to a higher CO2 with a set point. But if you went to another people density, like an auditorium, you again could increase the set point here to 765 because you have now more people per square meter. So the CO2 emission from people is higher. So the CO2, it's not a constant value. It depends on if you have a low emission building or a high emission building and the density of people. And there we talked about, but how is the emission? And Andy, he mentioned it's in the ASTM. You can find emission rates of CO2 from people. At the moment in the ISO and the EN, we are using 20 liters per hour for person for sedentary, kindergarten a little higher, department store 26.6, also because of higher activity. We don't distinguish between gender. But you can find more detailed values in the ASTM standard that Andy was talking about. So if you're now trying to compare the set point for demand control ventilation using some of the ASHRAE data, where we now take, for example, landscape office, where we have a little different in density of people in the ISO and the ASHRAE, but the required set point for the same indoor air quality, you see the set point in the ASHRAE, here's the set point is CO2 above outdoor. So the outdoor concentration is taken into account, is significantly higher than we are promoting in the ISO and the EN standard. And the same if you have a conference room or auditorium. And that basically because of the required liters per second per person we are using in ISO and EN, which are about a factor 3 higher than used in the ASHRAE standard. So we have, when you have been using CO2 today, is often like a pollutant. It's not really a pollutant, but you use a kind of mass balance equation to calculate how much is required to keep the CO2 below a certain limit. And one of the basic studies we had was the relation here between the CO2 concentration above outdoor and on the y-axis, the number of people who are dissatisfied, expected to be dissatisfied. So and that you see, we have the equivalent categories. But this percentage dissatisfied is only valid if people are the only source of emissions in the space. And normally we have other sources. That's why it gets a little more complicated to find out what is the set point needed. The 1000 ppm come from that 20% dissatisfied is about 650 or 700 above outdoor, and its outdoor is 300, 350, it gets you to 1000 ppm. But also the distribution may be in the space. The question, where should you put your sensor, may have an influence on how well your control is. So here is a case laboratory where we have different people sitting around the table. And we see the CO2, when you look in the exhaust air, that's the second to last. Here from a mixed air distribution was 592. If we now take it for displacement, it was 759. So even if you put it in the exhaust, you may get different values depending on your ventilation system. So position of sensors can be critical for your control. Then we have the outdoor. Here's some measurement taken around in Copenhagen, different heights and different positions, A, B, C, and D. It was made by some of my colleague Arsen and his group. I'm not going into detail with that. I would say in the ASHRAE addendum, it is accepted to have a default concentration of 400, so you're not forced to measure the outside. But if you don't, you may have an influence of the indoor air quality. And if you calculate, then about 50 ppm change of outdoor CO2 concentration may change the required ventilation with about 10%. So the best is always to look at the difference between indoor and outdoor. Finally, about air cleaning. Now, we have an annex, an AIVC annex, working on the possibility of substituting ventilation by gas phase air cleaning. There is an AIVC document which tells the concept. And the idea is to estimate the clean air delivery rate of the air cleaner. What is the equivalent of clean air the air cleaner would be delivering? So it's not a question about removing CO2. So to obtain that, it is required also to have a test method where you measure perceived air quality. So you're using a test panel of people. So if you now have an air cleaner and you have proved that it delivers what could be equivalent to a certain amount of clean air, same clean air as outside, then your set point also have to change for the CO2. So on the left here, you see for a single office, let's say category 2, we have about 397 or 400 ppm as set point. But if you had an air cleaner who basically provided equivalent clean air, you can put the set point for the control over the higher CO2 level. So I went through some of the issues you have by using demand control ventilation. It's not a fixed set point that works for all types of room, for all level of occupancy. You have to look at basically density of people and also the emission of the building itself to find out what is the appropriate set point to obtain the same air quality. Outdoor concentration, we in the standard take care of by using the difference between indoor and outdoor as our index. Then the position of the CO2 sensor can be critical, and air cleaning, if they have a clean air delivery rate, that may also influence the set point. So already now in ASHRAE 62.1, addendum 2AB, you can find more about the requirements and guidelines for demand control ventilation, and we will include them in the revision of the ISO and EN standard. Thank you.